Okay, so the next topic that we're going to be looking at in this trig unit is the topic of special right triangles. So there's two special right triangles that just pop up over and over again in trigonometry, and one of them is the 30, 60, 90 right triangle. The other is the 45, 45, 90 right triangle. Okay, so you notice because you have two 45-degree angles, then that of course means you're going to have two sides that are the same length. So those are the legs. So it is isosceles, and then the hypotenuse is represented by x root 2. Okay, this pattern is true for any 45, 45, 90 right triangle. So for example, if x, one leg, is 5, then of course it's isosceles triangle, the other leg is going to be 5 also. If you use Pythagorean theorem to then find the value of the hypotenuse, you could do 5 squared plus 5 squared equals c squared. So this is 25 plus 25 is c squared. 50 equals c squared. When I square root both sides, if you do a factor tree, you have 5 times 10. The 10 is 5 times 2. Okay, so you notice that you have two 5s, and then you have a 2 that stays behind. It does not have a partner. So when I find the hypotenuse, it is 5 square root of 2. Okay, so it fits this pattern. If x is 5, then this x would be 5, and then that would give you 5 root 2 for the length of the hypotenuse. Now this happens every time you have a 45, 45, 90 right triangle. So it doesn't matter what value you choose to be the length of the legs, that's the same pattern is going to hold for every 45, 45, 90 right triangle. So for example, if this side was 3, this side is 3, and the hypotenuse would be 3 square root of 2. Again, you could verify that using your Pythagorean theorem. Okay, so that's the pattern for 45, 45, 90. The pattern for 30, 60, 90 is this. Whatever this leg is, the short leg, I'm going to call this your short leg. This one is your long leg. And then this, of course, is your hypotenuse. So whatever the short leg is, let's say the short leg is 4. Then to go from short leg to hypotenuse, it's 2 times that x, or 2 times 4 is 8. Okay, then also from the short leg to go to the long leg, it's that short leg 4 times square root of 3. Again, this pattern is going to hold true for every 30, 60, 90 right triangle you have. So just as another example, let's say this leg was 10, then the hypotenuse would be 10 times 2, or 20, and your long leg would be the short leg x, which is 10 times square root of 3. Okay, and again, that pattern is going to hold for every single 30, 60, 90 right triangle that we have. Okay, so let's do some practice problems together. All right, so number 5, solve the special right triangles using the diagram below and the given measurements. All right, so in this triangle, you have a 45-degree angle, a 90-degree angle. So the other angle is going to be 45. Again, remember that your 45-degree angles are make an isosceles triangle. So if this leg is 7, then the leg over here is 7 also. Okay, so notice if we go back up to our pattern here, to go from a leg to the hypotenuse, it is that leg times the square root of 2. So the hypotenuse, go from a leg going to the hypotenuse, this would be 7 square root 2. Okay, number 6. Now number 6 is a 30, 60, 90 right triangle. So this one is going to match up the one above us on the left. Okay, this leg, the leg that's 5, this is the short leg. Okay, it is positioned the same as this 30, 60, 90 up above, but again, the short leg obviously is the shortest leg. It's also opposite your 30-degree angle. Your long leg is always opposite your 60-degree angle, and of course your hypotenuse is opposite your right angle. Okay, so following the same pattern as above, if I know what the short leg is, I can get to the hypotenuse by multiplying by 2. So short leg to the hypotenuse, 2 times 5, hypotenuse is 10. And then short leg to long leg is multiply by square root of 3. So it's the short leg, 5 times square root of 3. So there's the two other sides for that 30, 60, 90. Okay, number 7, and 8. Notice they both have 45-degree angles. So this is going to be a 45, 45, 90 right triangle. Now this time, instead of giving you a leg, I gave you the hypotenuse. So just to kind of do a quick sketch of our 45, 45, 90, the legs are x, the hypotenuse is x root 2. So whatever the leg is, multiply by root 2 to get to the hypotenuse. So if you want to go in reverse order, if I know what the hypotenuse is, but I want to go to the leg, basically you're getting rid of that square root of 2, so dividing by root 2. So to go from hypotenuse to a leg, that's going to be 11. Hypotenuse to this leg, also 11. Okay, on number 8, similar, but this one's going to be a little trickier because to go from the hypotenuse to the leg, you are dividing by square root of 2, but as on number 7, it's like, oh, divide by square root of 2. Well, I can just cancel out those root 2's and I'm left with 11. Okay, well, on this one, it's not going to be quite so easy. So I'm going to do 8 divided by square root of 2. Okay, but what we talked about yesterday was no radicals in the denominator. So we're going to have to rationalize and see what happens here. So multiply by root 2 over root 2. So this becomes 8 square root of 2 over, now remember, root 2 times root 2, you're multiplying the same thing by itself. That's going to be a 2. So we have 8 root 2 over 2. So you can simplify. I can simplify that down to 4 over 1. So then this side becomes 4 square root of 2. Now, since it's a 45, 45, 90, and we know it's an isosceles triangle, then that means this other leg is also going to be 4 square root of 2. Okay, so once I calculated it for one leg, then I can just transfer that to the other. Okay, now we have a couple of 30, 60, 90s. Now these triangles are turned a little differently from the ones above, so pay attention. You want to make sure you know which side is your short leg and which side is your long leg. So this is a short leg across from the 30, long leg across from the 60, and then of course this side's the hypotenuse. Okay, so just a real quick 30, 30, 60, 90, just to sketch so we have it in front of us. Short leg x, long leg x square root 3, hypotenuse 2x. Okay, so on number 9, we know what the hypotenuse is. So it's 12. Well, that's the value of 2x. So to go from hypotenuse to the short leg, it's just half that. Okay, so here, our short leg is over here. So if our hypotenuse is 12, our short leg is going to be 6. And then to go from short leg to long leg, short leg times square root of 3 goes to the long leg. Okay, so 6 root 3. Okay. All right. 30, 60, 90 here. Now the way this triangle is drawn, it might be a little bit hard to figure out, well, which one's the long leg and which one's the short leg. Well, again, remember, opposite your 30-degree angle, that's the smallest angle. So that's going to be the smallest side. That's going to be the short leg. Across from the 60, this is the long leg, and then hypotenuse. Okay, so this time what we know is the long leg. So the long leg is this one right here, long leg. So if I have the long leg to get to the short leg, well, to go from long to short, what's happened? Well, you're getting rid of that root 3. You are dividing by square root of 3. So same thing here. To get from long leg to short leg, you're going to divide that by square root of 3. Well, don't worry about rationalizing on this one, because you can just simplify that, and now my short leg is 9. Okay, now going from short leg to hypotenuse, multiply by 2. So short leg to hypotenuse, my short leg is 9, hypotenuse 18. Okay, number 11. So another 45, 45, 90. Okay, so remember your pattern for a 45, 45, 90, x, x, x root 2. Okay, well, this was 2 root 3, so that's kind of like completely, outside of what we've been looking at. But remember, 45, 45, 90, both of the legs are congruent, so this side would also be 2 square root of 3. Okay, to get from the leg to the hypotenuse, you multiply by square root of 2. So same thing here. Either leg, they're both the same. But if I take this leg, 2 square root 3, and you multiply it by square root of 2, you get 2 square root of 6. Okay, so here your hypotenuse is going to be 2 square root 6. Okay, so again, that might look a little weird, but we're just following our pattern, multiplying by that square root of 2 to get from the leg to the hypotenuse, and it ends up being 2 root 6. Okay, here's another 30, 60, 90. Again, it's not proportionate exactly like a 30, 60, 90, so use your angle measures so you can figure out which side is which. This side's the hypotenuse, of course. Across the 30-degree angle, this is going to be the short leg. Across from the 60, long leg. Okay, so now this 4 is the long leg. Well, okay, let me sketch our 30, 60, 90 so we've got it in front of us. X, 2x, x root 3. This is my 30, this is my 60. So this is the long leg, this is your short leg, and hypotenuse. Okay, so we are given the long leg. So to go from long leg, I can go to the short leg by dividing by square root of 3. So that's what I'm going to do. Go to the short leg, I'm going to go 4 divided by square root of 3. You're going to rationalize again. And you get 4 square root of 3 over 3. So 4 square root of 3 over 3, that's your short leg. Okay, short leg to hypotenuse. Well, multiply by 2. So to go this way, multiply by 2. So I have 4 square root of 3 over 3, and I'm going to multiply by 2. Well, multiplying by 2 is like 2 over 1, and that would be 8 root 3 over 3. So 8 square root 3 over 3. And I've got all 3 sides of my triangle. Okay, so you guys have an assignment. It is called Manipulating Special Right Triangles.